right, everyone, we're going to get started now. Thank you for joining us today for the Air Source Heat Pump Manufacturers Roundtable. Just really quickly, if you are to hover near the bottom of your screen, you can see that you have some options that include chat. We encourage you to chat anytime that you'd like to have a conversation among each other. If you'd like to ask a question of one of our panelists, please use the Q&A section. The Q&A section will help us to keep those questions organized and easily accessible when we come to the Q&A portion of our event today. Again, this event is being recorded. I will follow up with an email by tomorrow with a link to the recording as well as a link to our slides. And with that, let's get started. Joe, would you please advance the slide? We're happy to partner with CEDA on this special event. My name is Susan Harris. I'm a communications manager with New Buildings Institute, and this special event that we're putting on today is actually the fourth and last of a series that we've done with CEDA. And CEDA is a California Design Assistance Program that promotes electrification and decarbonization of new building construction, or major renovation. CEDA works in collaboration with project teams to reduce energy demand, consumption, and carbon emissions. They work on a variety of different project types, and they work in a variety of areas in California. We highly recommend you consider participating in CEDA. By participating with CEDA, you can receive a complimentary custom decarbonization analysis. You can gain analysis of energy costs and paybacks, receive financial incentives to help offset the costs of decarbonization measures for qualified projects, and demonstrate your commitment to high-performance building practices and design. And we all know that design teams are stretched thin on time and budget, but CEDA is now offering design team incentives on top of the incentives your project will get for implementing decarbonization measures. You can see there are a number of incentives that are available to you, including incentive rates, and again, we'll be sending out these slides so that you can look at the details that are related to those incentives. If you have a project that you'd like to be considered for these opportunities and incentives, please reach out to Jeff Glover or Tina Hendricks at the CEDA program.
Great. Yes, huge thanks to CEDA, and thanks to all of you for joining us in our fourth and final manufacturer roundtable of 2023. Today, we're focused on air source heat pumps. We know that heat pump or space heating is the top source of the top energy user in most types of buildings. So this is an important area to decarbonize. And today, we're going to dive in with some of the manufacturers, some of the leading manufacturers of air source heat pumps. And here is what our agenda is for today. And by the way, I'm Joe Wachunas, a project manager at NBI. We're going to talk a little bit about the heat pump market landscape, where we are, where we've come from, and then we're going to look at to our friends at Northwest Energy Efficiency Alliance and to where we're going, how we're going to advance heat pumps in the future. After that, this introduction period, we're going to turn it over to manufacturers and hear the latest and greatest of their residential and commercial products. We've got 4 manufacturers on our roundtable today: LG, Carrier, Mitsubishi, and Daikin. And during this time, please, as Susan mentioned, put your questions in the Q&A box, and we will do our best to group those questions together and put them to the manufacturers in the roundtable portion at the end of the webinar. So air source heat pumps, as we mentioned, are a really crucial decarbonization technology. One, because they're so efficient. They're 3 to 5 times more efficient than the other standard heating technologies like electric resistance or gas or other fossil fuels. And as you can see on the left, studies are showing they're even this efficient in cold climates. We'll talk about this a little bit today. And so they combine this efficiency for space heating, which is a huge energy use in buildings, and they run on electricity. And the great news that you may or may not know is that electricity is getting dramatically cleaner. With the rise of renewables and the decline of coal, electricity is now, emissions have dropped 36% since 2007. That's exactly what we need to see in order to rapidly decarbonize our societies. And heat pumps are a really rapidly growing technology. They've grown substantially over the last 10 plus years, and last year for the first time surpassed gas furnaces, as you can see on the left. This year they're holding at about 57% versus 43% for gas furnaces, according to HRI. And surprisingly, the top states for heat pumps are, you can see on the right, are in the Southeast in the United States. Really high penetration of heat pumps, but other states like California and the Northeast are making big moves into heat pumps. California just recently announced a goal of 6 million heat pumps by 2030, and many of the manufacturers on today were present to show their support for this stretch goal. So heat pumps are increasing quickly in the United States, but we have a long ways to go. Adoption is much higher in other and colder countries. You can see on the left this helpful chart from Nature. It shows heat pump penetration here, what percentage of, in the red dots, on what of heat pump penetration. So the United States is around 13% right here, but it also shows the amount of hours that a country usually heats, the amount of heating hours in a year. And you can see some of the really cold countries, Sweden, Norway, Finland, are up over 50 and 40% penetration of heat pumps for space heating. We're at 13%. Japan, of course, is the home of heat pumps and really high market penetration. So a lot of work cut out to rapidly transition to heat pumps in the United States. And today we're going to talk about how to do that. So let me introduce our panelists briefly, and then we'll get to the presentations. We're going to start off hearing from Susie Asmus. She's a senior program manager at the Northwest Energy Efficiency Alliance. Susie has been managing NEEA's residential HVAC program since 2015, initially with the ductless heat pump program, and now with the newly launched advanced heat pump program. Then we're going to turn it over to LG as our first manufacturer. Mark Thompson and William Robertson, both are experienced energy demand side management leaders with LG. We're going to then hear from Sean Lemons at Mitsubishi. Sean is focused on efficient cooling and heating systems for residential new construction. We are, I apparently have my bios a little bit out of order. Excuse me. After LG, we're going to be hearing from James Momprus. He's the energy and utilities sales manager for Carrier. He's got over 10 years of HVAC experience and plays an active role in maximizing clean energy opportunities for Carrier ductless and VRF products. Then we'll hear from Sean from Mitsubishi. And then finally, Jonathan Moscatello. He's a business development manager at Daikin North America. He's a nationally regarded expert in residential contracting and heat pumps and has worked at Daikin since 2021. So really excited about our panel today. Put your questions in the Q&A, and let's turn it over to Susie for our first presentation. Susie, go ahead, and I will advance your slide.
Okay, of course, best plans laid. I'm getting a notice that my computer battery is about to fail, and everything looks plugged in. So if I go black in the middle of my presentation, that's what's happening.
Okay, we could go back to you. Yeah.
All right, if you can advance to the next slide. Thanks for letting me join today. I am the residential heat pump manager at Northwest Energy Efficiency Alliance. So I'll be mostly focusing on our residential work. And before I jump into the specifics of what we're doing in heat pumps, I did want to give folks a little bit of context about who NEEA is and the work that we do. So the Northwest Energy Efficiency Alliance is a regional alliance where more than 140 Northwest utilities and energy efficiency organizations like the Bonneville Power Administration and the Energy Trust. NEEA has been around since 1996 as a regional collaborative, and we're tasked with pursuing highest value activities to secure energy efficiency for the region. Our funders, they represent more than 13 million energy consumers in Idaho, Montana, Oregon, and Washington. And NEEA is located in Portland, Oregon. The reason we work and represent this group as an alliance is to work on an economy of scale that individual utilities can't achieve. So as a collective region, we can represent a larger market when we're working and interfacing with market partners like the manufacturers here today, distributors, installers, government agencies, that kind of thing. And then NEEA also is able to pool risk on behalf of our funders, and we do that in the early stage technology work that we do, for example. Okay, if you can forward. The type of work that we do in the market, we investigate emerging technologies. We scan and assess new technologies, potential services, practices, that kind of thing. We also have a portfolio of programs and initiatives that we execute on and implement in the market. We work to influence codes and standards development and successful implementation of building codes as well, and efficiency standards, test methods, that kind of thing. The goal is to improve the material efficiency and outcomes of the market and these technologies. And then we convene and collaborate our stakeholders. And then finally, we do a lot of market intelligence, research and analysis, and provide insights back to the market and to our stakeholders to identify which new efficiency opportunities we want to pursue, and then what kind of progress we're making. Next, please. For those of you who are not familiar with NEEA, I also wanted to urge you to visit our website that is betterbuiltnorthwest.com. These are our market-facing resources, primarily supporting residential new construction with resources on home efficiency. And NEEA partners with folks like Earth Advantage and University Design Labs, other partners to support the new construction industry with adoption of advanced technologies and practices. And this site also hosts an HVAC sizing tool developed by NEEA. We offer it for free for use by the market. I've just demonstrated on this, it's a screenshot, but I wanted you to see where to find that tool within the site navigation. So you go to resources, and then there is the HVAC sizing tool right there. You can find it. So I just wanted to make sure folks were aware of that tool. Next slide. So one more slide before I talk about heat pumps specifically, about the Northwest market. So the Northwest market is a heating load dominated market. And because I think a lot of the audience listening today might be listening in from a cooling dominant market, I just wanted to make sure that that was top of mind as I'm talking about the work that NEEA is doing in the heat pump market. And so our work is really focused on heating technologies and heating efficiencies. That said, there is a significant growing demand in the Northwest for cooling. Historically, a lot of the homes have not had cooling, and we know that a lot of the drivers for heat pump demand in the Northwest is to adopt cooling. Also in the Northwest, there's a lot of inefficient electric resistance heat in homes. That's what we and our stakeholders are looking to address. And then another dynamic about NEEA and our work is that our alliance members are both electric and gas utilities. So the work we do doesn't focus on fuel switching or electrification per se. We're really focused on the most efficient technologies in both realms. And then finally, and really importantly, a note about our work is the cost effectiveness constraints. So many of our alliance members operate under strict cost effectiveness requirements. And heat pumps struggle to meet those requirements. And because of that, the work that I'll describe of what NEEA is doing is really aiming to work with the market to identify ways that we can increase reliable savings and without driving increased equipment costs. It's hard to do. I'm sure all of the manufacturers on the call can relate to that. But this is one of the reasons that NEEA is working with utilities in the market to curb the use of electric resistance backup heat, for example, in the heat pump systems. It's a really key component to saving energy. Okay, next slide. So we're ready to take a quick look into the heat pumps themselves. As I noted, part of NEEA's work that we conduct research that includes field research lab, modeling, consumer and market research. And there's so much happening in heat pumps these days, as you all probably know. Some of the research NEEA has been doing just over the past year or so includes investigating a wide array of what is happening with this technology right now. We've done a lot of research, modeling and lab research, some field research into the efficient features and capabilities we've identified, which I'll talk about in the next couple slides. We've been working, collaborating with folks on the new testing and rating procedure that is being developed for heat pumps. We have been capturing and documenting quality installation practices with a lot of market partners. We've conducted pilot investigations on thermal battery combo heat and water heating, and then also dual fuel gas and electric heat pumps, doing some consumer and product research on those. Next slide. So what are the Northwest Utilities and NEEA working on with these technologies? Our utility partners have been offering heat pump incentives to homeowners for over 10 years. They continue to expand and evolve how they're approaching the promotion of heat pumps, and NEEA's work in market transformation also provides support for those utility programs. At the end of August, NEEA just launched our new residential heat pump program. We're focused on identifying and pointing the market to the most efficient heat pumps available. Our previous program was focused on ductless heat pumps in a displacement scenario, but right now we're looking at all heat pumps that are installed in the market to increase their efficiency. We're looking at ducted and ductless, electric and dual fuel, primary and supplemental, but also new construction and replacement or displacement. Another really exciting space that we've been looking into this year is window or room size heat pumps that we've done some consumer research on. Next slide. How are we doing this? What's our approach? So NEEA is thinking about the savings as slices of a pie. And we are really focused on the right side of the pie, the dark blue and the kind of light blue hatched. Those are areas that we're looking at really baking in better savings, what we're saying like out of the box, that have less reliance on choices made in installation or actions in the installation process. So we want to make them as efficient out of the box as we can. We've worked with all of these manufacturers at the table today, for example, to pursue these opportunities. In addition, we are looking at improving the test procedure and the ratings for systems. And we want to start pointing the market to those systems that we can identify that have these greater efficiencies already available in the market. Next slide, please. Okay, I keep talking about improvements, features, capabilities. This is an example. This is the list of those. We've identified as a launch to our program some features that are high priority. We're going to continue to learn and consult with manufacturers, conduct lab and field research to verify these savings, and continue to seek new opportunities where we can find additional efficiencies. This visual illustrates that a lot of these improvements are additive within a single heat pump system to lead to overall greater savings. Some of them are not additive, but we're going to be pursuing these and other ones. And then not every improvement will be in every type of heat pump, but we're going to identify where these improvements are already found in the market and then help point the market to them. And last slide. I think I've kind of touched on all of these things, but this is kind of the overview of how we're engaging with the market and what our goals are with these products. But again, we need to work with manufacturers to identify which products in the market have these improvements already and work to grow the market share of these products and availability of these products, specifically in our region, but we're looking nationwide as well. And then we want to build the support in efficiency programs and with all of our market partners to support these the broadening of these improvements. And then finally, having these improvements adopted into federal standard, state codes, and utility programs. And the one thing we're most excited about is the recent advancements in the testing and rating procedure that are going to be we expect to be forthcoming. And they'll be taking into account new features specific to heat pumps, including a seasonal specific rating, for example. But there's a lot more we could dig into that. That's all the time that I have. if you just go to the last slide, if you want to reach out and learn any more about NEEA's approach or these features or capabilities, you can let me know. And we have recorded webinars that really dig into the details.
Thanks so much, Susie. Really appreciate it. I think we are going to want to take you up on that and dig in at the end on the testing and rating procedure and what that means in the Q&A portion. But thanks, appreciate that that high level look at focus areas to 2030 and beyond. Let's turn it over to our manufacturers, and we'll start with LG. Go ahead, Mark and William.
Okay, great. Thanks a lot, Joe. Thanks for the invite from you and NBI to present today. And Susie, that's quite a work list you have. I'm working on my transition from your full load of information to try to transition the participants to hearing about the products that we and the other manufacturers have. So let's go on to the next slide, Joe. And so, like the other manufacturers on the call, LG has a full line of residential and light commercial solutions. We call that division. We also have a commercial division, which is called Applied. But you can go to the next slide, Joe. So these are some of the key features of LG's residential lineup. We've been in the business selling heat pumps in America since 2014. Everybody knows LG probably from our refrigerators and televisions, but we have been making heat pumps and selling them in the US since 2014. So our brand is very strong in terms of its technology and its R&D. I think LG in 2023 won an award from Energy Star as one of their Sustained Excellence Partners of the Year. So working at LG, you learn that R&D is a big part of their DNA. So we won't go over all of these specific key features, but just to list a few that make LG stand out is, number one is the inverter technology that we employ. It's extremely efficient. The energy efficiency that we get from these machines is really incredible. There's quiet operation as another big feature. Also room-to-room control. And maybe I can let my partner, Bill Robertson, speak on that. There's probably not enough time to touch on everything, but we also have our ThinQ app, which is very useful and full of functionality for customer control capabilities. Bill, why don't you jump in if you have something that you want to add on one of these key features.
You're muted, Bill. Bill, you're muted.
Right. Sorry about that. Yeah, I was saying that there's a slide later in the slide deck for controls. Controls are a large part of the strength that LG has, because in the commercial side, a lot of the features that are found in the commercial controls, they've actually brought them into the residential side. But to Mark's point, LG has a lot of nice features that they've added to the equipment, like the Goldfin coating technology that they're going to be they've employed into the equipment to give the equipment good efficiency and also a good chance of a long life in terms of durability. But yeah, Mark, that we'll talk about the controls later.
Yeah, one thing on the right there that people might see is the Art Cool Gallery. We have something that maybe not a lot of people know in terms of our indoor units. There's another picture of it later, but it's on the right side of this screen below the high wall-mounted unit, and that is now it's a digital frame with airflow coming out of three sides of it, and the return air is at the top. It sticks out from the wall a little bit, but it's quite a unique feature that LG has, and you can put in your own picture into that picture frame digitally. So it's very cool. So you can even change the picture every day if you wanted to. But let's go on to the next slide.
Wow, I love that idea of the of a picture as your indoor unit. That's amazing. But somebody, maybe a quick question for you both. John's wondering if just typical decibel specs for the units. Some cities have ordinances of 50 decibels or below at night.
Geez, I'd have to check on that.
Okay.
Why don't we check on that and we can respond in the
Yeah.
in the
It'll be
chat.
dependent on different models. They're going to be different models with different ratings.
Okay, we can revisit it.
Yeah, so let's flip ahead real quick here to the next slide. Yeah, this is, we can just go over this quickly. I wanted to represent that for the single zone and the next slide, the multi-zone, we do have a full range of products. You can see the sizes across the top, the BTUs per hour or the tonnage. We have vertical air handlers all the way up to 48,000 BTUs. We've just added some additional air handlers that are multi-positional. We also have a lower cost line of those for new construction and other settings. And Joe, Bill, why don't you mention about the thin queue here?
Well, the thin queue is a means by which the consumer or the equipment owner can communicate to the equipment via a wireless network. And the dongle that you see right there is used as an accessory in some of the equipment that does not include the wireless capability in its own platform. But to Mark's point, LG is trying to broaden the features of the equipment, broaden the options for installation to be able to meet the greater diversity of install environments as we see more and more of these heat pump units being employed in the homes and other buildings.
Yeah, we can go ahead to the multi-zone. Great. And I wanted to add to, obviously for the commercial participants in the audience, LG makes a full line of applied products. We don't have time or space today to get into detail there, but we have a new inverter scroll chiller that we released this year. We have the DOAS systems, rooftop units. We have a new product I'll mention at the end called the Hydro Kit, which is an electric hot water solution. We also have air to water heat pumps, which are going to be introduced in January. So that's probably 50% of our business in America. It's probably pretty close to 50-50 between the residential and the commercial. So this page is just a little bit more about our residential multi-zone lineups. You see on the left, some of these outdoor units are designated as red. That stands for reliable at extreme degrees, which means that it's our cold climate products that Susie was talking about. And LG has wonderful performance at extremely low temperatures. Those LG red units are full capacity at 5 degrees Fahrenheit. And they go down to full operation at -13. The capacity is slightly less at -13 than 5, but the unit is still operating and producing heat. So we can go on to the next page. Yeah, here's the controls page you mentioned, Bill. Anything more to add here?
So what you have here is a representation of the different types of controls that we offer to control the equipment. And believe me, the features and the controls that they offer to set up this equipment to run in different with different pieces of equipment. If we're talking like supplemental heat, things like that, it gives you a lot. It gives the installer a lot of flexibility. And given the fact that a lot of these controls, again, are integrated with the wireless or the internet, it gives the equipment owner the ability to be able to interact with that equipment and turn it on, turn it off, or adjust the temperatures. So it gives them a lot of flexibility, and it makes the equipment, I don't know, it really improves the user experience.
Great. Yeah, you can go on, Joe.
By the way, the thin queue app will actually talk to your refrigerator and your microwave, which gives you more convenience to your home.
Great. So I'm not sure how much time we have left, but these pages are simply a lineup of our Energy Star 6.1 and cold climate products that meet those specifications. A lot of states have starting on January 1st of 2024, the Energy Star 6.1 heat pump specifications are in place. And you can see on the right, virtually many of these are both Energy Star and Energy Star cold climate. Some of the air handlers that I mentioned before that are lower cost items are not, but the majority of our products, including all of the LG Red products, are Energy Star 6.1 certified. You can go on, Joe. Thanks.
Really, that represents the fact that we offer this to multiple parts of the country in different climates, so we have options for.
Good point. Yes. Yep. And yeah, with just the last minute or two we have left, let's go to the next page. So LG has recently introduced a whole hydronic product line, and this is something new and fun and interesting to talk about. We have a heat pump water heater that Joe knows pretty well. It's a residential product, 55-gallon, super efficient, 3.75 UEF, and a very quiet operation. We also have the air-to-water heat pump coming that I mentioned, which initially will be a residential suite of products, monoblock. And then the Hydro Kit, I wanted to spend a minute mentioning that. This is an electric hot water system. We can produce outlet temperatures of 176 degrees Fahrenheit. There's a VRF system outdoor and a Hydro Kit indoor. It's a cascading system. There's two refrigerant loops. One is refrigerant to refrigerant, and then the other one is refrigerant to hot water. So you need a domestic hot water tank. But we're installing this product right now in literally tens or hundreds of buildings in New York City and New York State, because we've been approved by NYSERDA and the New York Clean Heat Program for a rebate for this product. So it's been in existence for about 3 or 4 years, but it's really taken off with the electrification mandates and requirements. And of course, older multifamily buildings are great candidates for this, as well as motels, hotels, any smaller business that needs electric hot water.
Right. Well, thanks, Mark and Bill. We'll have Mitsubishi next. We appreciate that a lot. Really great look at LG. Some really, I was making notes on some questions that we'll want to revisit. That air to water, exciting, and yeah, and the Hydro Kit as well. So thank you so much for that.
Sure, thanks.
So some folks are asking for all panelists to put their emails in the chat. So that's a good, really, I think you, we'll send out the slides as well afterwards, but if you both could put your emails in the chat, and our other panelists for easy contact afterwards. Sean, we do have your slides up next, so let's turn it over to you. Go ahead.
Thanks, Joe. Appreciate it. Yeah, Sean Lamons. I'm on the performance construction team. We are a national team, work with building professionals, and I mostly focus on residential new construction with some advanced sort of green building retrofits that sort of come into play there. We also work with multifamily applications, not so much on the commercial side, but we do work with and hand off to the commercial teams as well. Go ahead, Joe. So first I want to talk a little bit about the products, but first I want to run through and talk about the NEEA cold climate heat pump list. It's an exceptional list. It's an exceptional tool for us to have in the United States to be able to make choices from and look at the specs. But we need to double check our specs. These are two pieces of equipment from us. The top one is technically a cold climate list, and that little sort of orange-yellow diamond that's there identifies a true cold climate piece of equipment that will handle temperatures very low. And Joe, it's looking like our text has gotten all mixed up.
Kind of a little garbled. Sorry about that. We'll send out a better version with the
yeah.
slides.
The bottom one is a standard heat pump. It's usually not sold in cold climates, but because of its performance level, it actually shows up on the list, which can be good for sort of climate zone 4 types of applications where you don't get that cold. But in Denver, where I live, I would not apply a standard heat pump to do primary or all the heating for home or business. You'd have to have some other kind of backup heat to cover that red wedge of reduced capacity down below that. So that's really just calling out the distinction from what, as a manufacturer, we call a cold climate heat pump versus what might be termed or listed as a cold climate heat pump on the NEEP list. So just being aware of that. Go ahead, Joe. And to show another example of that is going to be our system versus an undisclosed system. So 1 outdoor, 2 air handlers versus 2 separate heat pump systems that are also on the heat pump list. What I wanted, the key items here are the additional heat strip that's needed for those systems that are on the list, but maybe not the right equipment choice for a cold, a Denver application where our design temperature is 0 degrees. You got to run a lot of resistance heat to take care of the house, and those systems are going to turn off at some point, and you have to carry the entire house on electric strip, which dramatically degrades the efficiencies of those systems. And the difference, if you look sort of left to right across this line, 190 amps worth of breakers required for the system on the right versus 65 amps of breakers for a system on the left. My key point here is just finding the spec, double check your spec, and make sure that you're not saddling the homeowner, the business owner, etc., with substantial increases in electrical needs, electrical costs, and long-term operation of based on that system choice. Go ahead, Joe. This is an example of this past winter. We had a polar vortex come through Colorado. It was -18 when we normally have a design temperature of 0 degrees, so significantly beyond the design temperature. And what I want to point out here is that the systems have some, in the same way that Manual J has some padding built into it, the specifications have some padding built into it for us, for the engineers to say, we are confident, we're comfortable to guarantee operation of the system in these conditions. Well, on this house, this comes from Sekar. He works for Helio Home here in Colorado. And he said, it was really cold, but the system worked great. We were comfortable. And the system never operated over 25 amps when the spec on that system is rated at 42 amps. And yes, they have a span panel in place in this house, but he didn't have to actually engage that span panel to shed load because the system was running efficiently, continuously, and it was below the electrical spec. So that's just something for the grid minded folks out there. I just wanted to demonstrate that. Go ahead, Joe. So getting into sort of key product highlights here, we have an extremely broad set of product options out there. I'm not going to talk about all of them. This is one that's been really popular in the United States and abroad. The MLZ Easy Fit comes in capacities from 6,000 BTU indoor up to 18,000 BTU indoor. 6, 9, 12, and 18. The 6 is a little bit smaller, so it fits in a little bit tighter spaces, but generally these systems fit in a 2x8 ceiling joist space. So it's really designed for retrofit, fully accessible from underneath. So those panels come off and you can access electrical and line set connections, etc. And there's a drain lift mechanism that will lift that condensate up, and so you can drain to daylight, gravity drain to a wet wall, etc. And very quiet. Go ahead, Joe. Another key item that I really like to talk about is this IntelliHeat hybrid heat pump. It's a dual fuel system. So the outdoor looks similar to the side discharge systems you're seeing around with heat pumps, but the indoor is a coil that replaces the air conditioning coil on top of your furnace. So now you can have the furnace for extreme temperatures or the size of the house. Existing houses don't always have the best thermal envelopes, and you want to hold on to that furnace for extreme temperatures or design day conditions, and that confidence that you're going to be able to keep the house warm when it gets really cold, depending on the size of the load. But now you can take that coil on top, size it for cooling, and now you're going to start to offset, 30, 50, 70, even upwards of 90, 98% of your heating. So you can switch from using so much natural gas to all electric very efficiently, and then choose the temperatures at which that changeover happens. It can be an economic choice, it can be a capacity choice, it can be a carbon choice. You can have your installer do the math on where that changeover happens. And it's a pretty intelligent system, and it learns sort of how you like to operate the house. Go ahead, Joe. In the light commercial space, we're seeing 6, 8, and 10-ton systems coming out. Those are 3-phase. They're part of the Smart Multi suite of products that we have. So same outdoor, can work with both the residential indoor equipment, the different types of cassettes, ceiling cassettes, wall cassettes, low wall air handlers, etc. Those would all be on a branch box. And on the right side, that outdoor unit can also match up with the city multi commercial equipment, and upwards of 12 residential M&P indoors, or upwards of 30 commercial equipment indoors. So some good specs on that as well, and plenty of line set to work with. Go ahead, Joe. This is a new product for us that's coming out. It's called the Hybrid VRF. So this is a dramatically reduced refrigerant system. So less refrigerant, it's air source or water source, and it can deliver to a water distribution loop within the building. This is a commercial application, and it works with that hybrid branch controller. It's a pretty exciting product, and allows the building owner operator to sort of future-proof that building against future changes in the market and the regulations, etc. And you're keeping the refrigerant outside of the building. So it's not really a monoblock approach, but it's sort of mimicking that monoblock approach to keep the refrigerant out of the building. Go ahead, Joe. This is a good guide that we have on our website, mitsubishicomfort.com. And I forgot to mention, we've got the links to all these resources down the bottom of each of these slides. Those links should be live when the PDF comes out. This will review resources for homeowners, for builders, for contractors, etc. And on the right side, you'll see a list of equipment that's qualifying for the 25C and the 45L tax credits. And there's many other programs, obviously, that people are hearing about, and there's a nice run through on some of that on this website. But that document is probably 6 pages long, and I don't know the percentage of our product, but I would say well more than half of our product is qualifying for those CEE tiered incentives. Go ahead, Joe. And just a comment for the performance construction team, which I'm part of. And we work with building professionals across the US on project support, education, collaboration, and industry advocates. So you'll see us out there at different events. And if you see us, please come up to us, ask us all the hard questions. We like to dig in. And we do it because we love it. We're a part of the team, and we do what we do because we believe in the work every day. I like to say I get to change the course of history every day with great people. So thanks so much, Joe.
Okay, having trouble unmuting. Thanks, Sean. Yeah, I totally +1 to that. Appreciate you all for changing the course of history with the heat pumps. A lot to talk about there, refrigerants and otherwise. Let's move through our panelists here, and we'll then get to questions. We've got a lot of good ones. Encourage any manufacturers not speaking, or Susie from NEEA, if there's any questions in the chat that you can answer, type and answer live, that'd be great. So let's turn over to James from Carrier to hear from our third manufacturer. Go ahead, James.
Awesome. Thank you, Joe. So for the most part, I'm definitely excited to be on here today. Carrier has been in the industry since 1904 as a leader, and we continuously keep coming up with new products and coming to the market to innovate and also drive the market in a direction that can definitely be beneficial for all who are purchasing our products. So what I'm going to be covering today, as you know, Carrier has a plethora of products out in the market, but there are two that really stand out that I would say are highlights right now for our team. And the first being our crossover solutions. And essentially what that is, it's bridging that gap between two formerly incompatible systems. And when we say that, you can think of your indoor units and also your outdoor unit, where it can now tie in with your conventional indoor unit, coils, and also furnace. And then you can tie that into your typical ductless outdoor unit, horizontal discharge. So this is a dual fuel product, and we really see this as something that can fit in the marketplace as definitely a problem solver. And to us, it's an innovator as it can fit so many different niches. Next slide. So for the most part, how it works is that, as I mentioned, it has that conventional ductless outdoor unit tied with your indoor either fan coil or furnaces. What it has is a 24-volt interface built inside. So for our typical lineup of ductless products, that's usually an accessory that you have to purchase separate. But with this product, it's actually baked in and no additional accessories are required for it. What's nice about it is that we see this as a good replacement a model for add-on replacement types of projects or for the replacement market in general, as you only need the suction line to be insulated and it's able to use conventional unitary line sets. So if you're thinking of your standard contractor going into a job site, sometimes they might look at ductless equipment and certain things can be a bit different from what they're used to. But with this product, it can really fit nicely in that, since it does use those conventional unitary line sets. And the fact that you don't have to insulate, only the suction line needs to be insulated on there. Next slide, Joe. So here we have a picture where you can really see the form factor advantages of the product, with that horizontal discharge being much smaller than what you can say your traditional top discharge systems or vertical discharge. With that, it's an extremely flexible product, and it is compatible with our residential fan coils and furnaces. So if somebody already has one installed in their home, and if it is compatible, then these two can tie in together. The tonnages go on from 1.5 to 5 tons. As I mentioned, it's a great replacement model and opportunity, and it comes in both a standard heat and a high heat model. One thing with that is that what we're looking at in the current climate right now, especially with the Inflation Reduction Act and all the local utility rebates, we really wanted to hit all of those standards in order to qualify. So this is an extremely competitive product when it comes to the ratings, to be able to hit many of the rebates. And also NEEP was mentioned as well earlier on the call. This is a product that would fit in that cold climate criteria if we're looking at those high heat models. So I would say Carrier is definitely leaning into this product on our ductless side, as it really does bridge that gap, and it fits that niche where between our traditional residential products and then also our ductless line. Next slide, Joe. Also, if we're looking at the commercial side of the business, one thing that we have rolling out is our Toshiba Carrier VRF U series. So a lot of innovation here. I think one of the key things in the market we're seeing now is the popularity of cold climate performance. And this is a product that can really fill that gap in our existing VRF portfolio, where it can operate in much better ranges, going all the way down to -30. I think that's a huge improvement from where we were at with our VRF products, and it makes this an extremely competitive product when it comes to the more northern climate zones. It also comes with a triple and twin rotary compressor and new inverter technology. And it also has additional communication protocols on there. So with this, we definitely think that in the commercial space, as we're seeing VRF become more and more popular, especially as more rebates and incentives come out in order to make it more of an affordable option, we're thinking that this product can really fit that niche and hopefully grow that popularity of our VRF technology. Next slide, Joe. So if we're looking at here, this is just a comparison on where we were at with our Toshiba Carrier VRF, where you see all the way on the left, and we go all the way down on our heating performance. You can see here that there's been definitely huge improvements. And now we're going all the way down to -22 Fahrenheit and all the way down to -30 Fahrenheit in our more advanced model, the Elite Heat. So definitely lots of improvements here. So if we're just to really wrap things up, if we're looking on our residential side, those crossover products are definitely going to be competitive out there to hit a lot of those rebates and incentives, and also the cold climate criteria for a lot of states and standards. And then also on our commercial side, we're seeing VRF grow in popularity. And obviously, as it comes to the more northern states, we needed better heating performance, and we were able to achieve that with this new lineup on our U series of VRF. Next slide, Joe. And I think that's most of everything I have. So with that, definitely, if anyone has any questions on our technology or wants us to help or lean in with a lot of the incentives or different utilities nationwide, reach out to me, whether that's on our residential side or on our commercial side of the business. We could definitely lean in there and see what different options that you all have. Thank you.
Thanks so much, James. Really appreciate that. Great. Well, we have one more panelist, manufacturer panelist, Jonathan Moscatello. I'll stop sharing, Jonathan, if you want to share. Then we're going to get to our Q&A. So keep the good questions coming, and we'll have a good 15 to 20 minutes for Q&A. Jonathan, go ahead.
Okay, Joe, can you confirm you see my slides okay?
Yeah, they look great.
Okay, great. I want to say I've been having so much fun with the question and answer feature, answering lots of fun questions that are in there. And I apologize if my answers are short and goofy, but I'm at a conference right now in like almost something like a closet to get away from all the noise, and I'm typing with one hand. So there's some weird, funny answers from me, but I thought they were great questions, and thank you for sharing them. I love going last on this panel because basically I could almost say Daikin makes all the same things. And the reason why I can say that, it's not just being a wise guy, it's in the rest of the world where Mitsubishi and LG, all these fantastic brands, where we all work, these modern variable capacity heat pumps or variable speed heat pumps are mature technology. We've been making them for years. We've been competing for the same kinds of products and applications. And the carriers overseas divisions as well. Like, while we do have, of course, some very specific proprietary little features, the general products are all really more similar than they are different. And so I don't have a tremendous amount to say, but I do have a couple things to share that I'm excited about. So if you don't know about Daikin, which I'm sure many of you don't, we're not a global consumer brand like LG and Mitsubishi, and we haven't been in North American market like basically Carrier, who invented air conditioning and heat pumps, right? This amazing company. We've been around overseas, and in about a decade or so ago, we purchased Amana and Goodman, which are a significant North American brand. So in the North American market, we go to market under these three brands, Daikin, Amana, and Goodman, but we own globally lots of other brands that some of you maybe have heard of on this slide. At Daikin, more recently, the chairman of the board challenged all the global companies to produce revenue profit units, like the classic business metrics for a manufacturing company. But we also are asked to achieve certain environmental goals, and we are obligated or required to perform on the environmental and social responsibility goals at the same level of success that we are for the basic business metrics. it's a really exciting time for us. I work for a team that is responsible for reporting on our success for environmental and social goals, and I specifically work with utilities and programs as the contact for the company in certain key markets. And so the cool thing is for Daikin, like, we have these high goals and mission, and our core technology is heat pumps. So we really are excited about the moment that we're in. And I thought I would just share with you some of the things about our company. You know, today we have these, you see this map of the globe where our main production centers are, but there are more than 100 locations in 28 countries around the world. They might not be a primary or a main production base. So we have this significant footprint globally, and we just love inverter technology. Inverter heat pumps are our passion. And a couple of years ago, like, let's say in 2017, we opened our North American factory in Waller, Texas, and which is it's amazing. It's the third largest building that's on a single story of manufacturing anywhere in the world. And it's here in the United States of America, and we make all Amana and Goodman products there, and and Daikin, most of our products. Now, the stuff that's traditionally inverter, modern variable capacity heat pumps are made in our overseas productions, but that's changing very quickly. And we're starting to make products in North America that have traditionally been made overseas. And we're pretty excited about that. It's a really special place where manufacturing, distribution, engineering, and all that is all under one roof. And it's really cool to be. It's just a spark for all of us working at the company. So for Daikin, we don't make industrial products by and large. We don't make any consumer electronics. We just make heating and cooling. And we make those products for commercial buildings and for residential buildings. And these kind of give you an overview of some of the things real quick, and then we can wrap up. For commercial buildings, we make similar products, as I mentioned, LG and Mitsubishi and Carrier. We call, this is what our industry calls variable refrigerant flow types of heat pumps. Our brand name is VRV. So Daikin makes our VRV line, and it's a incredibly extensive product line with every kind of indoor unit that one could want, and outdoor units that come in, oh gosh, heat pumps, heat recovery, single phase power, 3-phase power, some that operate on cold climates, some that operate on even colder climates. It's an enormous product line, and those are all made in the US, which is really, except for this water product, the one that's a small solid square that you see in the left-hand picture. That's still made overseas, but everything else is made here in the United States for the commercial VRV product line. You know, these are multi-zone heat pumps. They can have up to 128 zones, I think, per system, but some buildings have multiple systems on them. So if you can imagine a high-rise with lots of different spaces, it's designed to be able to control each room independently. Key to that, of course, is turning off unused spaces, and that's how we can hopefully achieve energy saving. So pretty awesome product line, but for us, what's become more our sort of new thing is adding more and more water heating, so capabilities to this product. And so imagine one of the zones becomes a water heating, domestic hot water heating product. And we also make this thing called Mega Cute, which we're basically doing our first launches in New York City in multifamily high-rise, where we just take over the hot water production from boilers that are present. And it's a dedicated heat pump, hot water heater for a large building. So our commercial VRV is most often used in offices and institutional settings, but it's going to be increasingly used, especially with hot water applications, I think, in multifamily. It's an interesting development, and I mean, it's an important technology for us, as it is for the other manufacturers on the call. When we look to residential applications, we have two kinds of heat pumps, at least how we look at them internally. There are ones that are ducted split systems. So these are mainly used in single family homes, sometimes used in multifamily, in those locations around the country where, you know, you have ductwork and a sort of larger apartment. But the unique thing about all this, of course, is that it really is designed to connect to ductwork and be a central system for the house or the apartment. Now, the cool thing about this product for us is we made it to be a very middle of the road in terms of price and performance. We call it Daikin Fit, and it's designed to fit in the middle of a product line. But because it's so inherently flexible, it fits everywhere. So you can put it with a gas furnace. You can put it as a standalone all-electric system. It's a very cool technology, modern variable capacity heat pump. The cool thing, the new thing for us is that we see more and more in the future that all of the heat pumps that we make will become this modern, we call them side discharge. They're very small footprint, very compact. They don't have as much refrigerant in them. They don't, use as much materials to make. They're very resource efficient. That's what we see in the future are more and more of our products that we make in this ducted split system category as being the variable speed. Similarly, we want these machines to be cloud connected, primarily for the homeowner and their, let's say, service provider, to provide better uptime, efficiency of the machine, and reliability. So in the old days, let's say, well, today, if you have a problem with your heat pump at your house, you have to have a contractor drive out, schedule that appointment, look things over, maybe go buy a part or come back another time to fix it. And we're finding more and more like those calls can be avoided in the first place by the homeowner calls the company, and a service technician that's at a computer workstation can do most of the diagnostic and sometimes even some of the solution over the internet online. And this just provides a greater efficiency and experience for everybody involved. So that's new on the ducted split system. On the residential ductless side of things, we were really excited last year to launch our Atmosphere product, which is it's a kind of a premium full-featured ductless split system, but it uses the new low GWP refrigerant called R32, which is where Daikin will be going with all of its products over the course of 2024. We're going to start slowly changing everything over to R32 ahead of January 1st, 2025, when we have to have everything changed over, at least today. So, that's our big thing for us, is converting our ductless products over to R32. And I think with that, we'll get significantly revised product line and maybe higher efficiency ratings out of our products. But if you don't know about ductless, for us, we think that the application for this is, in a couple ways. We see it increasingly used in new construction in those states that have, let's say, very rigorous or ambitious energy code. And that's most of the West Coast now. And so more and more we see a sole source of heating and air conditioning for new construction on a lot of the Western coastal Pacific Coast states. We also, as Susie mentioned in her introduction, have always thought of ductless heat pumps as perfect for single family and multifamily displacement of electric resistance heat. More and more our contractors are using mini splits or ductless heat pumps to reduce use of any existing fuel source in a home. So you put a ductless heat pump in a home, you keep maybe the gas furnace that's there for heating, but you use the ductless heat pump to be the primary heating source, and you turn on the furnace as needed to heat those times when it's needed. And we see that being used successfully by contractors all over. And then we see increasingly homeowners full on replacing the heating in their home, that use gas or electric resistance, especially a great option for those homes, like electric baseboard or wall gap. That's happening all the time, but it's really sort of unique to the markets where you see customers, looking for the electrification opportunity more fully. And that's, of course, on the Pacific Coast and then the Northeast in the US. So that's kind of the real quick for me and for Daikin. And there were in the chat or the question and answer, lots of very specific technical questions that we can't provide that information in a webinar format. So what I would like to share with people is we have a website called DaikinAC.com, which is designed to be a much easier place for a technical audience to find product literature that contains specifications and for every product. And so DaikinAC.com is your friend if you really are a technical audience and you want to learn more. In the meantime, my contact information is on the slide, and I put it in the chat. And that's it for me. Back to you, Joe.
Thanks, Jonathan. Yeah, appreciate it. Maybe you could stop sharing, and then we'll ask all our panelists to come on camera for our Q&A section. Just a reminder, folks, we will send out a recording and slides afterwards. But yeah, let's dive into some Q&A. Lots of great questions coming in, and we'll, as Jonathan said, we'll try not to get too specific on anything, but treat them some general themes. Susan, maybe start us off with our first question for the panel.
Sure, I'd be happy to. Everyone may have noticed that there's been a lot of questions around refrigerants. So panelists, if we could talk a little bit more about refrigerants, and I'll ask one of the questions that I saw go by. Feel free to use the raise your hand functionality if you want to make sure you get an opportunity to talk about it. You know, one of the challenges with these kinds of events can be knowing who's going to talk next. So that might help us with that. One of the first questions I saw around refrigerants was, what refrigerant options will be available to replace R-410A?
Yeah, could you talk about that? Go ahead. I'd like to start first.
Yeah, I could speak for Carrier on that. Carrier, for the most part, is going fully in the direction of R-454B as our choice of new refrigerant going forward.
And what GWP is R-454? If you know off the top of your head, James.
What is it again?
It's all right if you need to.
What is it?
Check it out or look it up.
Don't have it at the top of my head. I believe
It's in the
right
ballpark
under
of 490.
yeah, about
It's just under there. Yeah, it's 475, something like that.
yeah, that makes sense. I know it's definitely under 700.
Where Mitsubishi's looking at 454B as well. Now we have some R32 products internationally, and so we'll see some transition on that R32 product line, but eventually things moving towards 454B residentially and probably most of the commercial. And we've got other refrigerants as well that come into play around the world. And we also have some CO2 based refrigerants. What is it, 744? Is that what it is? Something like that.
Yeah, and from LG's perspective, we're switching the total product line to R32 on January 1st of 2025.
And Jonathan, you mentioned
R32 in my presentation. Yeah, we're all R32. Someone did ask me about air to water heat pumps, and specifically we use R290 in one product in Europe. It's worth saying that I get asked all the time. There were tons of questions about our air to water, like boiler replacement or domestic hot water. And R290 is so much easier to use in other countries than it is ever going to be in the US. And so I think for people working in the US space, I would just say R290 is something we're looking at, because we have to look ahead to the future because of the way refrigerants are regulated. But it's really hard under the way code and safety, building safety is regulated in the US to ever imagine being able to use R290 in all but the smallest quantities of what we would call as a unitary system or a monoblock, like something where it's not serviceable by a technician. It's a sealed system that the person doesn't touch. Like there are some refrigerators and other products that have very small amounts of R290 in it. And beyond that, I just don't see it being able to use. Refrigerant products, we tend to need more refrigerant than would ever be allowable in all of our products. And so for us, these air to water products that we make and use overseas, we could or would bring to the US, but it is a much more difficult market to even consider bringing those products into the US. And that's why we haven't, even though for years we've made them and sold them successfully in Europe, and they would be good products in the US if we could figure out how to navigate all of the complexities of the US market for those products. So
that's interesting, Jonathan. We do hear that a lot, that R290, aka propane, is a great refrigerant, but there seems to be a lot of interest in changing codes to allow that to be. Do other manufacturers share that that outlook that R290 may never be allowed in the US, or is anyone more optimistic about?
I'll take a stab at that real quick. And I have to take my Mitsubishi hat off for a moment to answer this. For just someone in the industry, I think 290 is a great option as a natural-based refrigerant versus a synthetic-based refrigerant. I think there are upsides to that significantly. And oddly enough, you can go down to your local hardware store and buy 20 pounds of propane and carry it in your car and bring it in your house and store it wherever you want, as long as you're safe about it. But I honestly don't think that we would allow natural gas to become a thing if we were considering bringing on natural gas. Like, what if we were just to look at propane being distributed within our natural gas pipelines? It's higher pressures. I get it. I just find it a funny inconsistency in the US market.
Yeah. Okay. Well, thanks for that answer on refrigerants. Maybe starting with you, Susie, we got a lot of questions on potential heat pumps to provide both space and water heating. Someone is even talking about marrying all the fridge, the heat pump dryer. Could they all run on one unit? Is NEEA, and then we'll turn it over to the manufacturers, looking into these combo systems? And do we see them as a viable future?
Yeah, NEEA is definitely engaged with some manufacturers in the emerging technology space on heat and water combo. And we have a few presentations. I am not engaged directly in those, so unfortunately I can't speak really in detail to those, but we do have some presentations that have been recorded that I can put the link, and probably some reports that I can pull off of our NEEA.org website that will give some indication of what the work is that NEEA is doing and kind of our take on what we've seen so far in the market. The other thing I will say is, Joe, you and I were at the Energy Star conference a few months ago, and there were some exciting new technologies that people were talking about combining a lot of the different technologies within a home. And so I am excited about those, but I can't speak to them.
Great. Well, thanks, Susie. Yeah, it'd be great to have those links and reports. Yeah. Any other, Mark or James or William, any thoughts on the combo system? I think you did allude to them in various parts of the presentations, but combining water and space heating in one unit.
Bill, you have any comment? Yeah, go ahead.
Well, I think that, if you look at the Northeast and the prevalence of wet heat and the devices that are currently used to meet those demands, it makes obvious or logical sense that we develop equipment, heat pump based equipment to meet those demands, and that's what we're working towards. So, as Mark had discussed in his initial presentation, we've already released to the marketplace some of the initial offerings to meet these requirements. And I've seen in some of the questions, some of the concerns over operating temps, and from our perspective, how we've developed the equipment to meet those requirements, being able to deliver up to 179 degrees water temp. And at the end of the day, it's going to be based on the size and the ultimate demand that the job is, or the project's going to require, and of course that's going to drive how large the system is going to be necessary to meet those demands. But I answered one of the questions and basically said, look, you're going to start seeing a lot more of this equipment coming to market, and what we have right now is just the first level of examples.
That's exciting.
Yeah, I'll add in a little bit there. Hope I didn't cut you off there, James. We do have water source and air source to water equipment on the commercial side, and I think it's we're seeing the commercial side coming along faster in the US for us. than the residential, but we do have products. 60%, roughly 60% of our sales of our products in the EU, for example, is hydronic, we'll say. I don't know whether it's air source or water source, but is a hydronic system. So we're going to see more and more of that product coming out over the next few years as the industry continues to push and consumers continue to ask. And I will say too, if there's something in particular you see in other parts of the world, specifications that show up in the EU or UK or Australia or wherever, if you've got the gumption, pull that up, share that directly with the manufacturers and say, hey, I'd really like to see this. Here's the business case. The key is building the business case around it, because large manufacturers have to make lots of complex decisions around creating and bringing product to market. It's an extraordinarily detailed process that I think most people don't appreciate, and I didn't appreciate until I started to learn a little bit about it. So if there's something that's really important to you and you want to rally some folks and ask for something in particular, reach out to folks that can connect you with the right product planners and create a business case for it.
And I would say I definitely echo the same sentiments as Sean with that. It's assessing what the demand is, especially for newer products on the commercial side. It's definitely very important for us, especially now as we're developing a lot of new products to hit the market. But I think for Carrier, we're definitely in a position right now where we can go in many different directions, mainly because of the acquisition of Viessmann recently. And that's a European manufacturer that's already been in that space. And they also have different solar options and different types of technologies. So now as that acquisition is really rolling through, we have access to different technologies, and we're currently looking into all of that. Nothing on the books yet, ready to be announced, but I do know our team is just looking into different options that are available in the market. I would say we're well positioned for that, but the more we see demand, it'll be a lot easier to make that transition and be able to develop new products.
Well, that really seems to segue into a question that we have here about the market. We can see the yearly sales of heat pumps through September 2023 seem to have decreased 13% compared to 2022, according to HRI. But gas furnaces are down 24% year over year. What is the reason for the soft market, do you think?
I've talked to a lot of contractors, and I think there's a mix of things happening right now. I think the one that's probably most interesting for me, and I'm guessing maybe for the audience, is that there's a lot of confusion over all of the stimulus and incentive in the market. And I think there are people waiting to make purchases thinking that there's a rebate coming tomorrow, and they should hold off until they get that rebate. And I, of course, I try to help people in the trades understand that the IRA rebates were designed mainly for a low and moderate income homeowner. And if you talk to people in homes, you better figure out how to politely say to them that, you may or may not qualify. What is your household income, and how does it compare to the LMI data, which you can easily find on the web? And most contractors are absolutely terrified of having any conversation close to that with a homeowner. And so these essential things that need to happen, need to be talked about at the kitchen table, aren't being talked about, and homeowners are not buying at the same rate that they were in the months and years ahead. The other thing that I see is that contractors, due to the volume increase they saw over the pandemic years, were raised their prices. They didn't have the labor to grow and didn't necessarily want to grow as their business size as fast. And so one of the strategies that you do as a contractor is you raise your prices until people stop buying, and then you ratchet back. And the prices that are still in the market, I think, have scared away a lot of consumers. Something that should cost probably 15 to 20,000 units in some markets is going for almost 30 or 35. And I think if you're a homeowner shopping, you see enough proposals come across your inbox or across your kitchen table for these $35,000 amounts, and eventually you leave the market. And I believe those two processes are going on.
You know, with that and what Jonathan was saying, I think this issue is definitely multifaceted. For one, we've seen a downturn in housing starts. Most likely that's due to high interest rates and inflation. So if we're looking at more so new construction, and they're most likely going to go AC furnace, that's going to play a role. But also those high interest rates will also impact homeowners who will choose to either most likely finance their replacement system. As Jonathan was mentioned, it can be extremely expensive. So because they would have to go that financing route and those higher rates, that could definitely pose huge issues there. And then also gas furnaces being down more than heat pumps is likely caused by the reduced housing starts and a homeowner's financial ability to replace their entire system when an AC fails. So that's really all going to play a role also. And they can choose to replace their AC when it fails as well without even replacing their furnace. They have that option. Me personally, if I had to go that route and it's less expensive, I would definitely take that. So there's many things layered into this where I think it's more of a complex problem rather than black and white, like we want it to be. We definitely, would want electrification, more heat pumps, but I think there's many factors that play at the same time.
Yeah, that's a great point, James.
I'll take a quick stab at it too. I think it absolutely is complex, but if you sort of take that high level simplicity piece, people are feeling pressure on the financial side, with the economic conditions of various types. So, you're gonna feel that pain, that pressure, that wait and see scenario, and I think that's the primary reason for the soft market, in my opinion. It has to do with rates, has to do with other purchasing decisions, has to do with new products coming out, new incentives coming up, et cetera, and so on. But fundamentally, if people have a little less confidence on the financial side, they're not going to go out and spend this year when they could do that next year or 2 years out. I will also say that the furnace downturn was happening far before the higher interest rates. So the fact that furnaces are down 2x what heat pumps are down, I think it's a trajectory that's going to continue on. Heat pumps can do what furnaces do almost entirely today with the right technology, and heat pumps are coming for air conditioners next. So of the 14 million pieces of equipment that are sold every year, heat pumps can do both of them. ACs can only do one, furnaces can only do one. It's going to be 95%. This is me just putting out a number. It's going to be 95% heat pumps in 10 years.
Wow.
And don't forget about the Section 25C IRA tax credits, because those are available now back to January. So that's still a really healthy incentive for the marketplace. People may be hearing more about the rebate programs that are well into 2024. From what I'm hearing, as recently as today, Massachusetts said they don't expect to get their rebate IRA programs up until fall of next year from now, late fall next year. So there is the 25C tax credit for those that have the income to support that kind of a credit.
Thanks. I think we're getting close to time, maybe one or potentially two more questions. We appreciate everybody's time here and the great turnout we've had. Maybe starting with you, Susie. We did get a question in the chat about variable speed versus single or dual stage heat pumps. We saw from Jonathan that there's an X over the big boxy heat pumps in the future. Is that NEEA's focus? Is that where the market is heading, towards all variable speed heat pumps? And then we'll hear from manufacturers as well.
Yeah, I would say ideally we would like to see the market move to all variable speed heat pumps. The particular approach that we're taking for our current program, however, is to, anywhere we find an opportunity to lock in additional or increased savings into an installed system, we want to promote that. So as non-variable speed systems are still going in, we would hope that they would also adopt these greater efficiencies, or that expansion of these features or capabilities would also be happening in those markets while they are still viable in the market. But you know, our goal would be that the whole market is moving to variable speed heat pumps.
Thanks. Any other comments on the push to variable speed?
Yeah, if you want expensive heat pumps full of refrigerant, which makes when leaked, of course, right, makes an impact on global warming, then you should have cube-shaped heat pumps. If you want really affordable heat pumps with very little refrigerant in them comparatively, or half, let's say, not very little, half or so, then you should have side discharge units. And if you have any doubts in your mind on the subject, reach out to me and I can bore you to death on the subject.
I was going to say, Jonathan, I always like that Jonathan makes that, provides that illustration and makes that point, because the amount of refrigerant in the variable speed really does have an overall environmental impact as well. And that's always appreciated.
Yeah, for sure.
And I'll add in just a little piece of that. The reason that these more, I'll just say advanced pieces of equipment can do the job with less refrigerant is that they're basically generating higher pressures, right? They're managing the temperature and the pressure of the refrigerant in a different way with they're working with more pressures. The key change, and this is for everybody listening to this, please encourage your technicians to double check what pressure they need to test their system at, right? And it's probably going to be in the ballpark of 600 PSI using nitrogen. Pressure test your system beyond the status quo of an air conditioner at 350 or 400 PSI and calling it good. It's not good enough. These systems will operate at 600 PSI and they need to be pressure tested at 600 PSI to eliminate that refrigerant leak.
I figure I'll chime in a little bit too. Carrier's opinion on this might be a little counter to everybody else's. For the most part, we're into just supplying the market with all the best options possible. And one thing that we see is that there's cost constraints in different technologies. And because of that, you know, we would like to offer as much as possible, and we let the market essentially go in what direction that they want to go with making that selection. Carrier definitely has a huge inverter technology portfolio, and we're definitely pushing that as heavy as possible. But then we also have our single and multi-stage products as well. And we're seeing that those are still selling, especially in different markets where they have cost constraints, or maybe builders, for example. There's still markets for that. So that transition might not happen as fast as everybody wants into everything going full variable speed. But for right now, we're definitely just continuously supplying the market with what the market is demanding right now.
Thanks for that, James.
Well, we just have a few minutes before we're at time. I'd like to pose one last quick question and pass around the question to everyone here on our panel. California just convened manufacturers for a goal of 6 million heat pumps by 2030. Is that goal reachable?
I'll go first.
Oh, go ahead.
Sorry. Go ahead, James.
I was just going to say, I think it is a reachable goal, mainly because of the broadness of that statement. When they're saying heat pumps, it's not exclusive to just HVAC heat pumps. It's heat pumps throughout the whole industry. If we're looking at it holistically like that, then that number definitely is, I think, possible. If it's HVAC heat pumps, it might be a different metric, but in heat pumps in general, I think that is something that can be hit.
Yeah, I agree with James. They mean heat pump water heaters as well as HVAC, as well as maybe heat pump dryers or other appliances. But yeah, LG's all in on that. We were involved. We were one of the manufacturers in that press release a few weeks ago with the CEC. And if any state is going to do it, it's going to be California, right?
Sean, any thoughts to add there?
I have some colleagues out there that see it as a, you know, it's a bring it on challenge, you know, of course. And I will also say that we need all players. We need all good players. Like, we need to show up for the game, play a good game, That's what the sport is about, right? Everybody's got to bring that mix of best practices, as James alluded to. You know, let the market decide, but you also have to bring your A game, and I think we can do it.
Thanks. How about you,
I'd
Jonathan?
like to see the air conditioning or air-to-air heat pumps for space conditioning capture as much of that 6 million out of all selfish reasons. But I think for California, it'll be much easier to have a pretty good proportion of the 6 million be water heaters. And I think that might be a little bit more what results from all this. But I think it was looking at the market that for HVAC in general, I don't know how many millions. I don't think we'll produce 6 million installations under normal conditions of HVAC from now until 2030. Like the volume of unitary replacement is not quite that much in California. So if every system was a heat pump that would have normally been put in, and we can capture a little bit more than that, we'll get pretty close. It really is a matter of like continuing to have impactful state incentives and a lot of awareness raising campaigns. And if we don't miss a year where people kind of just, and in the contracting space, follow business as usual, and instead they switch to heat pumps and offering consumers heat pumps, I think that'll give us the best chance of making 6 million, at least for our side of the industry. The water heating guys, you know, it's a different business, and I really shouldn't. I don't know it well enough to speak to it, but it's worth noting. Like Sean said, or one of our team said, it's 6 million heat pumps, not heat pumps for air conditioning. It's all types. So
I'll also say that all the manufacturers involved here have partners that do manufacture globally. So if you look at heat pumps globally, they are more widely adopted in general. And if we're looking at 10x growth on certain segments of the market just in the United States, yeah, it's a lot of heat pumps. It's a lot of work to be done, but it's within. I believe it's within capabilities as long as the products are. I'm a huge fan of proper specification. I really don't want to see bad products put in at a cheap price because the installer think that's what the homeowner wants, is the cheapest thing. It should be the right product. I'm a big fan of the right product for the project. So that's going to be the challenge.
Agreed. Panelists, thank you all so much. I feel like we're just scratching the surface of this conversation, but I'm glad that we had this time together to do that. And I hope we have another opportunity to continue the conversation.
Yeah, same. +1 here. Huge thanks to everyone for joining us today, for sticking it out for this amazing conversation. Thank you to our panelists, Susie, Bill, James, Mark, Sean, Jonathan. Great discussion. Like we said, we'll send out slides and recording as soon as we can. And you've got all the contact information for the panelists, and we'll send that out as well for further conversation. Thanks so much, everyone. Huge
Thanks for having me.
And we'll talk to you all
yeah,
soon.
thanks for having us.
Bye,
See you,
everybody.
everybody.
Thanks a lot, Joe.
Thanks
Cool.
all.
Thank you, Jeff.